today we will be using the quadratic formula again to find x-intercepts. So again, they can ask you to find x-intercept solutions. They all mean the same thing. Even roots are another way to represent the answer when we're trying to come up with a solution for the x values when y is 0. And so that's what we're going to end up doing first, is setting y equal to 0, and then also getting everything onto one side. We need to put it in the standard form of ax squared plus bx plus c equals 0. And so that's what we have right now. Y equals x squared plus 4x plus 3. And so again, we're setting this equal to 0, the y value equal to 0, and that will give us our x-intercepts. We're going to substitute the numbers in there. And we've got the opposite of b, so negative 4 plus or minus the square root of b squared. So 4 squared minus 4 times a, which is 1, c is 3, all over 2 times by 1, because that's what the a value is. And so we do some work there. Negative 4 plus or minus the square root, and then we have 16 minus 12 all over 2. So we do a little more work there. Negative 4 plus or minus the square root of 4 over 2. And then we can take the square root of 4, which is 2. And then we can set up our two problems. And so we've got one of them is this, negative 4 plus 2 over 2. And we have negative 4 minus 2 all over 2. So when we do that work, negative 2 over 2 makes negative 1. Over on this side, negative 6 over 2 makes a negative 3. Those are the two x-intercepts. That's what we're solving for here. Well, taking a look at the next one, move that 15 back to the other side, and it's just an opposite operation. So what happens is it switches signs when you move it to the other side. And then from there, we go ahead and use that quadratic formula. So we're just going to substitute the numbers in there. So the opposite of 2 plus or minus the square root of 2 squared, so b squared, that's the 2 value here, minus 4 times a, which is 1, c is negative 15 this time. And this is all over 2 times by 1. So we do some work there, negative 2 plus or minus the square root of 4, and it's going to be a plus sign because the two negatives will cancel out to make a positive. And this ends up giving us 60. This is all over 2. So negative 2 plus or minus the square root of 64, which is a perfect square. And so we do that work, negative 2 plus or minus 8 over 2. And then we can set up our two problems. Negative 2 plus 8 over 2 and negative 2 minus 8 all over 2. So we end up with a 4 over 2, which makes 2, is one of the answers. Negative 10 over 2, which makes negative 5, is the other. Well, those are the x-intercepts for that one. Let's take a look at the next one. We have it already in our form that we want. So the problem needs to be in that quadratic equation form of ax squared plus bx plus c, and that's what we have. So we just substitute the numbers in there. So this time the opposite of a 1, which is negative 1, plus or minus the square root of 1 squared minus 4 times a, which is 1, c is negative 12. All over 2 times 1, which is what a is. Negative 1 plus or minus the square root of 1, and then another plus sign because the two negatives cancel out. And that makes 48 when I multiply those numbers, and this is all over 2. So negative 1 plus or minus the square root of 49 over 2, and the square root of 49 is 7. So negative 1 plus or minus the square root of 7 all over 2. We can set up our two problems. Negative 1 plus 7 over 2. And we have negative 1 minus 7 all over 2. So when we do that work, we end up with a 6 over 2, which just makes 3. And then on the other one, here we have a negative 8 over 2, which makes a negative 4. Those are our two x-intercepts. Next one doesn't have a b term, so that means it's 0. Remember, you can write it this way, x squared plus 0x minus 9. And so when we do the work, we have 0 plus or minus the square root of 0 squared minus 4 times 1, which is a, and c is negative 9. And this is all over 2 times by 1. So we do that work. We just have the plus or minus sign now because the 0 doesn't need to be there. And we end up with just 36 all over 2. So we got two answers here. 6 plus or minus 6 over 2, which would be 3 halves. Which would be 3 if we do that work, but let me show that step here. we would have a 6 over 2, which would make 3. And then we also have negative 6 over 2, which makes negative 3. So our two x-intercepts. Well, this one we need to move these two terms over. I'm going to add the 4x and subtract the 7. So watch what happens. It becomes still 3x squared, but I move that 4x over. It becomes positive 4x. Move the 7 back, it makes a negative 7. And then from there, I can use my quadratic formula to solve. And so we end up with a negative 4, because it's the opposite of that b term, over plus or minus the square root. Then we've got 4 squared minus 4 times a, which is 3, it's c, which is negative 7. And this is all over 2 times by 3. So we end up doing a little more work there. Negative 4 plus or minus the square root of 16 plus, because another plus sign, the two negatives cancel out, 12 and 7 multiply to make 84. And this is all over 6. So we do that work, negative 4 plus or minus the square root. And let's see, that makes 100 all over 6. We take the square root of 100, it's 10. So now we have negative 4 plus or minus 10 over 6. From this point, we can set up our two problems, negative 4 plus 10 over 6, and negative 4 minus 10 all over 6. And so here we end up with a 6 over 6, which makes 1. Or on the other side, negative 14 over 6 makes a negative 7/3. And those are the two x-intercepts. Taking a look at this last one here, we've got a 2x squared plus 3x plus 10. So we go ahead and substitute our numbers in there, opposite of b, so negative 3. And then we got to square the 3 because that's our b term, minus 4 times a, which is 2, and 10, which is the c term, all over 2 times by 2. So negative 3 plus or minus the square root of 9 minus, now just a minus because there's only one negative here. An odd number of negatives makes a negative, and that makes 80. And we're going to have a problem here, so maybe you see it already, but when we go ahead and take that subtraction, or do that subtraction, we end up with a negative 71. And it's not just that 71 is not a perfect square. The problem is the negative sign. So let me highlight that right here. This negative sign right here underneath this radical makes it so we don't have any x-intercepts. There are no x-intercepts. And so that would be our answer. Good luck on tonight's homework.